Hello, welcome to my recorded classes. This video we are discussing section number 5.3 Gauss-Jordan reduction to solve a system of linear equations. This is a topic from the course Mathematics for IT from chapter 5. So let's start the topic. Section number 5.3 Gauss-Jordan reduction to solve a system of linear equation. Already in the previous section 5.2 we are studied Gaussian elimination for finding solution of a linear system, correct? Almost the same procedure here we are using row transformation. By using row transformation, how can we find the solution? By using Gauss-Jordan reduction method. Okay, so first we need to study what is the meaning of reduced form, Gauss-Jordan reduction, reduced form. So a matrix is said to be reduced form. It should satisfy these four conditions. Okay, the leftmost non-zero element in each row should be 1. That is the first condition. I can show here with the example, another slide. You can see each matrix. Okay, so in a matrix, if you are taking each row starting non-zero element leftmost, this is the left side of the matrix, correct? This is the right. So leftmost non-zero element, 0 no problem, non-zero element in each row should be 1. See here it is 1. Okay, 0 0. Now 0 1 0 0 0 1. Just note this example so that you will understand all the properties correctly. The leftmost non-zero element in each row is 1. See the first row, row number 1. First number, non-zero number is 1. Second row, row number 2. See, first number is 0. 0 number, no problem. Non-zero number, other than 0, the beginning number should be 1. See, here it is 1. Third row, here 0, no problem. Here also 0, but beginning non-zero, other than 0 number should be 1 number. This is the first condition. Now, second condition, the column containing leftmost 1 in a given row. Zeros have above and below 1. That means already we marked leftmost 1, correct? These are the leftmost 1. Now this leftmost 1 number, downside and top number should be 0. See this one, down number all 0. For example, this one, up number 0, down number also 0. For example, this one, top number 0. So each leftmost non-zero 1, down number and up number should be 0. That is the second condition. Each column containing leftmost 1, above and below should be 1 number. Now next condition, the leftmost one in any row is to the right of the leftmost one in the preceding row. That means, for example, here it is 1, correct? We can mark with another color. Here it is 1. Now next to row 1 should be the right side of this one. See, this is the right side of this one. Now next to row 1 should be right side of this number. See the right side of the number. This is the meaning of the third property. That means each leftmost one in a row, in any row, right of the leftmost one in the preceding row. Preceding row, leftmost one, right side should be the next row 1 number. Okay, so this idea like, so 1 here it is coming means next to row 1 should be the right side. Here it should be the right side here, not left side. Next to row 1 should be the right side of here, this right side, 1 here. This is the third condition. Fourth condition, any row consisting entirely 0. For example, if any row having full number 0, all the numbers 0, it should be last. See 0 0 0, one row full zeros, correct? This row should be last. We need to write, we not write middle or first or second, like should be last row, that one. So if any matrix satisfies these four conditions, that matrix we are calling reduced form of the matrix. You can see the examples one by one, each properties. For example, a matrix is said to be reduced form. You can see one by one. Leftmost in each non-zero element, leftmost non-zero element in each row should be 1. See, first row non-zero element is 1. Second row non-zero element is 1. Beginning 0, no problem, other than 0. Third row, see full 0 it is, no problem. Okay. Now second property, the column containing leftmost one of a given row, 0 above and below 1. See, for example, this one below number zeros, For example, this one, below and above numbers are 0. For example, this one, above number 0. So wherever 1 coming, that above and below number should be zeros. Okay, leftmost one I mean. Now third one, the leftmost one in any row is right of the leftmost one in the preceding row. That means here 1 coming means next row 1 should be the right side here. This is the right. Next row 1 should be the right side of this number. This is the meaning third property. Okay, one number in the beginning row leftmost one, next row leftmost one should be the right side of this one. Okay, that means here next row leftmost should be the right side of this number 1. This is the meaning, the third property. Okay, now fourth property, any row consisting entirely 0 should be below of any row having at least one non-zero element. So 0 row, full 0 number means it should be the last row. This is the fourth property. So a matrix is satisfying all these properties, 4 properties. That matrix we are calling reduced form of the matrix. Okay, or row reduced echelon form we are telling, or we can say simply reduced form. Now we will do some examples, and before example, now what is the use of this reduced form? Okay, how can we find the solution of a system by using Gauss-Jordan reduction method, or from the reduced form how we are finding the solution of a system of equation? For example, here one 3x3 system I was given. Okay, a1x, b1y, c1z equal to d1. So this 3x3 system, correct? 3 equations and 3 unknowns. Basics we are discussed already in 5.2 section. This is 3x3 system. We need to calculate x, y and z. We need to solve the system. So to solve the system, find x, y and z. First write the augmented matrix, AB matrix. First we need to write the augmented matrix, that is the AB matrix. You know how to write AB matrix. Each equation, x behind number a1, y behind number b1, z behind number c1, right side number d1. A matrix means behind number matrix, capital B means right side number matrix. We will put a line in between for identifying A matrix and B matrix. This part is A matrix, this part is B matrix. Now transform this A matrix. Okay, this A matrix we need to transform into reduced form by using row transformation that we discussed in 5.2 section. So transform this matrix into reduced form. Okay, reduced form already we discussed. What is the meaning of reduced form? First number 1, down number 0, then next diagonal number 1, up number 0, down number 0, next diagonal number 1, up number should be zeros. This is the meaning reduced form. So change the A matrix into reduced form. After that find the values of x, y, z from the reduced matrix. Okay, so that we will get the solution of that linear system of equation by Gauss-Jordan reduction method. So this is the procedure. I am not going much theory part, already we discussed in the before classes. Okay, so let's start the question. Okay, exercise 5.3. Exercise 5.3, question number 1. Check whether the following matrices are in reduced form or not. Only we need to check reduced form or not. If it is not reduced form, which number is wrong? We can tell which number is wrong. Okay, so for example, first one, 0, 1, 1, 0. Is it reduced form or not, that matrix? You can think. No, it is not reduced form. Why the reason? First property is okay. Each row starting number is 1, 0, then 1 is coming. 0 no problem, as I told you. Next row also starting number is 1, then 0. First is okay. But the third property is violating. What is the third property is coming? If first row 1 here coming, next row 1 should be the right side of this one. Correct? Should be right side. But here it is coming left side. It is not possible left side. Correct? So this number is wrong. This number is wrong. That means this number is wrong here. It is on left side, not right side. Preceding row, that means the before row 1 right side, it should be that one. So we can write this number is wrong. What is this number? Which number? We studied already the general form of a matrix. First number we are calling A11, A12, A21, A22, like this. We can write the reason in simple way. Which number is wrong here? A21, correct? It should not be 1 there. A21 is not correct, correct? I hope you understood that one, the reason. A21 is not correct because A21 should be 0 there, correct? So A21 should not be 1, okay? Should not be 1, okay? So 1 should not be that place. So that is a simple reason we can write A21 should not be 1. Okay, now we will go to the second question. Matrix 1, 2, minus 2, 0, 0, 1, 0, 0, 0. So is it reduced form or not? We can check it. Each row first number is 1, correct? First row first number is 1. Second row first non-zero number is 1. Third row complete 0 row. So no problem. Now where is the mistake? The 1. You can check the 1. Here this is the 1, correct? That 1 number down numbers are 0. It is okay. Now next one is here. Down number 0 but top number is not 0. It should be 0, correct? Wherever the leftmost one in each row coming, the down and up number should be 0. This is the second rule, correct? So that second rule is violating here. So we can write this is not in reduced form because this number is wrong. Which number? Minus 2. That means A13, first row third column number. A13 should be 0. So this is not in reduced form, correct? So that is the simple reason. Only just highlight the number, which number is wrong. So we can write that number is not correct. Okay, now we will go to the C part of the question. What is the C part? 1, 0, 0, 0, 0, 0, 0, 1, 0. Which property is violating? Is it reduced form or not? It is not in reduced form because you can see the second row. Complete 0. Complete 0 should be last row, correct? So we can write 0 row should be last. Okay, 0 row means the second row, R2. R2 should be last. We need to transfer into last. So that is now violating. So it is not reduced form. Now question number D, we can check reduced form or not. 1, 0, 0, 0, 2, 0, 0, 0, 1. Which rule is violating? It is obvious, correct? It is not in reduced form. So which rule is violating? Here the starting leftmost number is 1, but here the leftmost one number is not 1, correct? This should be 1 here, this place. Here the leftmost is 1, correct? But the second row leftmost number is not 1. So which number is wrong? A22 should be 1, correct? It should be 1. So it is not in the reduced form. So these are the good examples for identifying for understanding the properties of the reduced form. Okay, now we will go to the questions. Using the reduced form, how to find the solution of a system of equation. First we are doing a small question, 2 by 2 system. How can we find the solution? Solve the system of equation by using the program Gauss-Jordan reduction. Solve the system by using Gauss-Jordan reduction. 2x plus y equal to 6. X minus y equal to minus 3. Okay, so we will start the question. We need to solve. We need to find x and y. That is the question. From this 2 by 2 system, we need to get what is x, what is y. So start with the augmented matrix, A, B matrix. Matrix A, B equals matrix. What is the A matrix first? X behind number 2, y behind number 1. Put a line, right side number is 6. Second equation, x1, y minus 1, z is, right side number is minus 3. 2 by 2 system is comparatively easy, not much steps. But when we are going to 3 by 3 system, many steps will be there, lengthy steps, okay. So here, now what we need to do? We need to change the A matrix into reduced form. This matrix should be in reduced form. Now it is not reduced form. So what we will do? First number we need to change into 1 first, correct? That is the pivot number. So what you do for that? We can divide. Before divide, you can check the down number. Here it is 1, correct? Already 1 is there. So we can interchange the first row and second row. So 1 we will get in beginning. So how to write R1 interchange with R2? So equivalently matrix. This transformation I already discussed in 5.2 section. You can refer about the transformation in the questions from 5.2. Okay, so first row means second row. We are interchanging second row full. 1 minus 1 minus 3. First row we write second row. 2, 1, 6. Now it is okay. So now we can see the first number is 1. So this number is the pivot number. Now pivot number, down number should be 0. This is the next we need to do. This number should be 0. So which row we need to change? We need to change the second row. You know how to change 0. We are studied in 5.2 recording. So R2 we need to change. So R2 plus default, opposite of the number 2 minus 2, multiply pivot number coming on first row, R1. Minus 2 multiply R1 plus R2 gives R2. So you can enter your calculator this rule like minus 2x plus y, or you can do manually also. So better by calculator. X means the first row, row number 1. What is the row number 1 here? 1 minus 1 minus 3. Y means the second row, R2. What is the second row? 2, 1 and 6. Then you can calculate what is minus 2x plus y. Okay, minus 2 times x number plus y number. Okay, so equivalently when you are calculating, you will get the matrix. Equivalently you can get the matrix. Use the calc button. First enter this one in your calculator, minus 2x plus y. Whenever you want x, you can use the alpha button, correct? Minus 2 alpha x plus alpha y. Then after that press the calculation. Calculator will ask what is your x number. X number is 1. Press equal to. Calculator will ask what is your y number. That is 2. So immediately you will get what is the answer, equal to 0. Then again press the calc button, minus 1 and 1. Okay, you will get 3. Then calc button again, minus 3 and 6. You will get 12. So I am writing here, first row no change, 1 minus 1 minus 3. Second row we got this new output, 0, 3 and 12. 0, 3 and 12. So the first step is over. Now we will go to the second step. So this was the pivot before. Now just this diagonal number. This number should be 1 now. This should be 1. So what we will do? We need to change the second row. If you want to change a number 1 means that row divided by the same number, that is 3. All the number in that row divided by number 3. So equivalently matrix, first row no change. We can write the first row, that is 1 minus 1 minus 3. Correct? 1 minus 1 minus 3. Second row complete number divided by 3. 0 by 3, that is 0. 3 by 3 is 1. 12 by 3, that is 4. Now, so this number is the pivot number now. Correct? Pivot number coming which row? Second row. Now pivot number, top number we need to change into 0. Correct? So which row we need to change? R1. So what we need to do for changing 0? R1 plus is default. Opposite of minus 1, that is 1. Multiply pivot number coming row, second row. Correct? Pivot number coming which row? That is second row. So 1 multiply R2 plus R1 gives R1. So equivalently matrix. Okay, equivalently you can check the numbers. You can enter this one in your calculator, 1x plus y. X means the second row. Second row is what here? 0, 1, 4. Y means the first row. What is the first row? 1 minus 1 minus 3. Now you can enter your calculator 1x plus y, x plus y. So x plus y means 0 plus 1. You can press calc button if you are using calculator. Calc x number 0, y number 1. You will get 1. Then calc 1 and minus 1. You will get 0. Then calc 4 and minus 3. Correct? You will get equal to 1. So we can write here the answer. First row becomes 1, 0, 1. Second row same 0, 1 and 4. Okay. Now we go to this matrix. See, you can see this matrix. It is in reduced form now. Reduced form. Because first number 1, down number 0, next diagonal number 1, top number 0, reduced form. Now what we do now, row number 1 change into equation, row number 2 change into equation, so that you will get a solution. What is the row number 1 here? Row number 1 means 1, 0, 1. Okay, that means first number stand for x, second number stand for y, and this is equal to right side. So what is the equation here getting? 1 multiply x, x, plus 0 multiply y means 0, equal to 1. So we got the solution x equal to 1. Now second row, what is the second row? 0, 1 and 4. First number stand for x, second number stand for y. This is the right side number. So when we are writing equation, 0 multiply x, 0. No need to write. 1 multiply y, y. What is y? Y equals 4. So this is the solution of that linear system of equation. Solution is x equal to 1 and y equal to 4. I hope you understood this question. You can practice like this more question. One more question we can do. Question number 2. Solve the system of equations using Gauss-Jordan reduction. So here x minus 2y 4, 3x minus 5y equal to 7. We need to solve, we need to find x value, y value by using the program Gauss-Jordan reduction. Correct? So first we are writing the augmented matrix A, B matrix equals matrix 1, minus 2, 4. Second equation 3, minus 5, 7. Now you can think about the first number. First number is 1 here. This is the pivot number. Now one number down number should be 0. This number we need to change 0. That means we need to change the second row. So how to change a number 0? You know, R2 plus is default. Opposite of 3, minus 3, multiply pivot number coming on first row. Row number 1. Pivot number is coming on first row. You can use that one. Equivalently, the matrix we are getting here. Use this operation. Minus 3x plus y. X means the first row number. What is the first row? 1, minus 2, 4. Y means the second row. What is the second row? 3, minus 5 and 7. So enter your calculator. You can use the calc button. Okay. Once you minus 3x plus y type in your calculator. Calc 1, 3. Okay. So you will get 0, 1 and minus 5. These three cases. Then enter this as usual before we discuss it. So what is the equivalent matrix? We are writing first row no change. 1, minus 2, 4. Second row 0, 1, minus 5. Okay. 0, 1 and minus 5. Now what is the next operation we need to do? Next transform. This is 1. Now diagonal this number should be 1. Already that number is 1 here. So that is the pivot now. Pivot coming which row now? Second row. Now pivot number, top number, it should be 0 here. So which row we need to change? First row. So R1 plus is default. Opposite of minus 2, that is 2. Multiply pivot number coming row, that is second row. So you can try that operation yourself. You can do, that is 2x plus y, correct, where x means the second row. Second row means 0, 1, minus 5. Y means the first row. What is the first row? 1, minus 2, 4. So what answer we are getting? I am just writing here. You can check by calculator later. So matrix, first row becomes 1, 0, minus 6. Second row becomes 0, 1, minus 5. Now you can see this matrix is in reduced form now, correct? This matrix is in reduced form because first number is 1, down number 0, next diagonal number 1, up number 0. Now change into equation. So first row you can change into equation, second row you can change into equation. What is the first row here? You can see 1, 0, minus 6. Second row what? 0, 1, minus 5. So first number stand for x, y is not z, equal to right side number. Here also x, y and equal to number. So what is the equation representing first row? Means 1 multiply x, x equal minus 6. 0 multiply y means 0. Now second row representing equation is 0 multiply x, 0. 1 multiply y, y equals minus 5. So we got the solution. Solution is x equal to minus 6, y equals minus 5. Okay. Hope you understood the 2 by 2 system. 2 by 2 system comparatively easy to find the solution. Now we will do one question in 3 by 3. It is little lengthy. I will write the steps here. You can verify by calculator later the row operations. So this is the question. Solve the system using Gauss-Jordan reduction. 3 by 3 system here. Okay. So I am starting with the AB matrix. Matrix AB equals matrix first row 2, minus 2, 1, 3. 3, 1, minus 1, 7. 1, minus 3, 2, 0. Okay. Now first number should be 1. But here it is not 1. So you can check the down columns. Here it is 3, but here it is 1. So we can interchange the first row and third row. If not 1 in the column, then you can divide after that. Okay. But check the possibility transferring first. Okay. Interchanging first. Equivalently matrix. Third row we write the first row. 1, minus 3, 2, 0. Second row same, 3, 1, minus 1, 7, 2, minus 2, 1 and 3. First row become third row. Now it is correct. The first number. This is the pivot number. Now what we need to do? Pivot number, down number. This number and this number we need to change into zeros. So that means we need to change second row, we need to change the third row. So R2 changing means R2 plus is default. Opposite of 3, minus 3, pivot number coming in the first row. Correct? So minus 3, R1. Same if you want to change it to R3 plus is default. Opposite of 2, minus 2, multiply pivot number coming row, first row. So this operation you can check by calculator. I am writing the answer only here. Calculation you can try yourself. So we will get the matrix. First row no change. 1, minus 3, 2, 0. Second row, when we are using that transformation, we will get 0, 10, minus 7, 7, 0, 4, minus 3 and 3 is the third row. We are using that transformation. I am only giving the steps. Calculation you can do by calculator. Now, once you finish this number 1, now we will go to this one. This number should be 1. That is the next operation. So, which row we need to change? Second row. So, if you want to change 1, that same row divided by the same number 10. Correct? R2 divided by 10. So, equivalently matrix. First row same 1, minus 3, 2, 0. Second row becomes 0 by 10, 0, 10 by 10, 1, minus 7 by 10, minus 0.7, 7 by 10, 0.7. All the number in that row divided by 10. Third row same 0, 4, minus 3 and 3. Now what is the next one? So now the pivot number is this one. It is coming on which row? Second row. Now pivot number, down number and top number should be 0. So here it should be 0. Here also we need to change into 0. So which row we need to change? First row we need to change and third row we need to change. Correct? Because we need 0 there. So what we do? R1 plus is default. Opposite of minus 3. 3. Multiply pivot number coming on which row? Second row. Same R3 we need to change. R3 plus is default. Opposite of 4 minus 4. Multiply pivot number coming on the second row. Okay. So once you calculate using calculator, you will get equivalently matrix. As I told you, I am writing only the steps. Matrix. First row you will get like 1, 0, minus 0.1, 2.1. Second row no change, 0, 1, minus 0.7 and 0.7. Third row we are using that transformation. You will get 0, 0, minus 0.2 and 0.2. Okay, you can verify. Now, which number we need to change? So first we changed this number 1, then we changed this number 1 above and below 0. Now we need to change this number, should be 1. So what row we need to change? Third row. So what we will do? Third row divided by the same number, minus 0.2. Okay. So equivalently matrix, when we are changing, equivalently matrix. First row no change, 1, 0, minus 0.1, 2.1. Second row no change, 0, 1, minus 0.7 and 0.7. Third row complete number we divide by minus 0.2. So we will get 0, 0, 1, minus 1. Now what is the next operation? This 1 is the pivot now. Okay, pivot is coming which row? Third row, correct? Third now, row number 3. Now pivot number, top number, this number and this number should be zeros. Okay, so which row we need to change? R2 and R1. So how to change 0? R1 plus is default. Opposite of minus 0.1, 0.1. Multiply pivot number coming on third row. Multiply R3. And here opposite of first R2 plus is default. Opposite of minus 0.7, 0.7. Multiply pivot number coming on third row. Okay. So equivalently matrix, if you are doing the transformations, you can check, you will get the answer like 1, 0, 0, 2. First row transformation you will get this answer. Second row transformation you will get 0, 1, 0 and 0. Third row same 0, 0, 1 and minus 1. Okay. So now the matrix is in the reduced form. You can see this matrix now. It is in reduced form. I hope you understood up to this. Now once you got reduced form, now we are going to do the calculation x, y, z. So first row change into equation, second row change into equation, third row change into equation. So what is the first row? 1, 0, 0 and 2. Second row 0, 1, 0, 0. Third row 0, 0, 1, minus 1. So as I told you, first number stand for x. These are all x. Second number stand for y. Third number stand for z. And right side number equal to. Correct? So from the first equation, okay, what is the solution from the first row? 1 multiply x, x. 0 multiply y, 0. 0 multiply z, 0. So x equal to 2. First some number we got. Second row, 0 multiply x, 0. 1 multiply y, y. 0 multiply z, 0 equal to 0. Third row we will get 0 multiply x, 0. 0 multiply y, 0. 1 multiply z, z equal to minus 1. So this is the solution of that linear system by using Gauss-Jordan reduction. Okay, so 3 by 3 you can see it is little lengthy, more steps are there. The idea I hope you understood. You can practice now the questions. Okay, idea is more important. So what you do, first number should be 1, then after this 1 down number should be 0 number. Second step. Third step, this 1 diagonal number should be 1. Then after that this 1 down number should be 0, up number should be 0. After that again what we will do, we will go to this 1 diagonal number should be 1. After this, the last step we are doing, this 1 top number should be zeros. So this matrix we are calling reduced form. Okay, I hope you understood. Okay, this number, this method, you can practice this question. This question you can check what answer getting. Okay, you can comment that one. So this is the idea, Gauss Jordan reduction, how to write a matrix in reduced form, and using reduced form how can we find the solution of a 2 by 2 system and 3 by 3 system we are discussing here. So thank you very much. Thank you for watching this recorded class. Please subscribe my channel for getting more recorded classes. Thank you very much.